Increasing and decreasing function. So, determine the function whether decreasing or increasing. So, the derivative of function may be used to determine whether the function is increasing or decreasing on interval in its domain. So, if fx is greater than 0, so at each point in interval I, then the function is said to be increasing on I. So, if x is less than 0 at each point in interval I, then the function is said to be increasing on I, because the derivative is 0 or that does not exist only at critical points of the function. It must be positive or negative at all other points where the function exists. For example number 1, determine the function of if x is equal to x to the power of 4 minus 8x to the power of 2, whether it is increasing or decreasing. And determining intervals where a function is increasing or decreasing, so you first find domain values where all critical points will occur. So, for that, the value of critical points x is equal to negative 2, 0, and 2. So, testing all intervals, the left and right to these values for if x is equal to 4x cubed minus 16x. So, you can find that, so if prime x is less than to 0 on negative infinity and negative 2. So, if prime x is greater than on negative 2 and 0. So, if prime x is less than on positive 2 and 0. So, if prime x is greater than on positive 2 and positive infinity. So, therefore, if the f is decreasing on negative infinity and negative 2 and 0 and positive 2, and increasing on negative 2 and negative 2 and 0 and 2 and positive infinity. So, let us try to find where a function is increasing or decreasing. So, for example number 2, if x is equals to x to the power of 3 minus 4x for the interval of negative 1 and positive 2. So, let us plot it including the interval of negative 1 and 2. So, starting from negative 1, the beginning of the interval of negative 1 and 2. So, at x is equal to negative 1, the function is increasing. So, it is continuous to decrease until about 1.2. So, then it is increases from x is equal to 2. So,